So today we are going to look at the PCB overview and understanding the concept, and we are also going to design schematics and designing a board, and also we are going to generate manufacturing file so we can uh, give it to the manufacturer, China or India, something like that. Okay. Before going to PCB, we need to know basics of electronics and basics of some prototyping tools. Okay. So, if you don't know breadboard, I just give an introduction. Breadboard actually is a fundamental piece of when you're doing prototypes. It's very quickly we can do some prototypes. So he says this is a breadboard, and these are some parallel connection, and you can see this is a vertical connection. Breadboards. So why I introduced the breadboard is when you do college projects or some BA projects, you don't need to make PCB uh, uh, at the time. So you need to first test your project using breadboard. Then you can convert the breadboard project into PCB. Okay. So first make sure you done and everything work properly in the breadboard. Then try to convert the breadboard project into PCB. Okay, you can use Arduino for the breadboard, Raspberry Pi and everything, something like that. After PCB, for the PCB, we don't need to use an Arduino, but we can use microcontroller Arduino, like the 80 Mega 328B or something like that. Okay. So, uh, so what is a PCB board? PCB is acronym of printed circuit boards. So anyway, all I know when we get a result will be. So PCB is actually the main part of a hardware product. Actually, it's a body of hardware product, and one thing is firmware, the software, and another one is a PCB. This both contain the hardware, the complete hardware product. Okay, you can see. I think everyone familiar with the PCB. What is PCB and everything. So what make a PCB is a printed circuit board, and what make it to transfer the electrons through the board. Okay, so this is actually the overview of PCB. PCB is sort of like cake, and there's some layers in between them. The first layer we call silkscreen. We can go through deep into that later. And another layer called solder mask, and another layer called copper, and we have a substrate called FR4. Okay. So when we do PCB, we need to add everything in the design manufacturing file. What comes in the silkscreen, what comes in the solder mask, and everything. So we need to know what are they. So the first material is in between the FR4. So FR4 is basically a fiberglass material. I think you will be familiar with this kind of FR4 when you do the proto board. Like after the breadboard, we also do some proto board. So proto board is basically a fiberglass material. Okay. So these actually come here. And next we have a copper sheet. This is actually the tricks going to happen. This copper sheet actually in this layer, the only copper sheet can conduct or transfer the electrons from one side to another side. Okay, and all other are just non-conductive materials. And this one is copper. And you can see the copper is a layer of thin copper foil which is laminated on the board with the heat and adhesive. Okay, just laminated with the top of this material. Okay. Actually, this one actually is a single layer board. When we refer to multi-layer PCB, there are actually two copper side inside. You can see there's a two copper sheet in between the substrates. Okay, this is a two-layer PCB. In our computer motherboard, we have 48 layers, 24 layer PCBs also. That means it has 48 layer of copper sheets inside the PCB. Okay, I think you got it. And next thing we are going to get it, the solder mask. Okay, the solder mask actually giving the green color. This is actually for protecting the copper from the scratches or conductive bits or make it happen something like that. You can see the this is actually the solder mask. Okay. When we manufacture a PCB, we can choose what color we want to use. We can use red, blue, yellow, and everything. And the green one is the very common color. That's why it's also very cheap. Okay. So this is the solder mask. And next we are going to look at the Silkscreen. Okay. Silkscreens as an important one. This is actually this basic color is a white color, so we can also change whatever we want to. Okay, this actually symbolical address of some components. You can see in our main PCB. I'll see. You can see these are some C17, C16, C15. These are actually the Silkscreen. Okay. The Silkscreen can be add letters, numbers, symbol, and actually it's actually nothing to do with the designs, but it's actually better to when we add some components and we need to know what value is the resistor is, what value is the capacitor is, and when we come to the SMD, the capacitor and the resistor are actually the similar package. We can't find any difference between these two. So these kind of Silkscreen when we add will help us to identify. Okay. We often use the Silkscreen labels to indicate the what function each pin or LED. Like you can see, this is actually we can see this one is symbol actually for an LED, and this actually notation as a power. So this actually power LED. Okay. And next, we need to know some terminology before getting started with the PCB designing. There is two type of components, actually more than two, but right now for the simplicity we only learning two type of components, SMD and through technology. SMD is a surface mounted technology, and through is just we normally use in our breadboard or protoboard, something like that. You can see this is a through component, so we can solder in the below part, and this is surface mounted components, and this both are resistors. That's interesting. So this is also actually a resistor, and this is actually a resistor. You can see this is the R27 resistor. So this is actually the Silkscreen. Okay, and this is R37. This is actually the resistors. Okay, you can see this is also a Silkscreen. So next component. When we design PCB, there is something called component. The component basically the name it says components refers to a part in a circuit. This actually referring to a part itself always the same as the symbol. So the difference between the component is when you can see these are the different kind of resistors. And these are also different kind of resistor. You can see 1206, 0805, and a different kind of resistors. So these are the components. And another thing called symbols. Symbols are actually the symbolic meaning of components. This one is a symbol of resistor. This one actually this is the actual component we are going to solder in our PCB, but this is our when we design our PCB we use these symbolic components. One thing, make sure that I'll show you the another example after that. And another thing called packages. Packages actually is a 3D model of a component. Okay, this is actually the actual component, but this is a symbolical representative of a component. And this is actually the package for the 3D component. So suppose just think we are designing a PCB with enclosure. And after designing the PCB, we need to make sure that it fits into the enclosure. Okay. So we have some components like relay. It's a bigger in size, right? So this have some height and breadth and width. Okay, so we need to add some kind of 3D model of the relay module. Then we can only make sure that this will be fit into our enclosure and everything. So for that we are using packages. Three-dimensional shape of the component. Okay. And another one is the footprint. Okay. The footprint, you can see the right side. This is the footprint. R6, R5, R7. And the R4, R2, R3 is actually the symbolical representative. Okay. Not a symbolical actually. It's actually not a symbolical representative. It's actually the footprint also. But these two are actually the same resistor values. But the problem is it's actually the different in size. Suppose you want to add this kind of resistor in your PCB, okay? But every resistor has same symbol, okay? Will be the symbol for this resistor and this is it. So we need to make sure that we are choosing the right packages, okay? We don't, if we use these kind of resistor, these kind of packages, the piece will be broken. So we can save any space. Our design will be a failure. Okay. So make sure that anyway, don't be afraid. I'll show you everything in practical using Eagle. Okay. Next, before designing a PCB, we need some kind of materials in our hand. The first thing we need a BOM, that called bill of material. What thing we are going to use, like we mentioned, which package we are going to use for the resistor, which package we are going to use our capacitor and everything. Everything need to be clear before we are going to design a PCB. Okay. So first thing we need a bill of material, and also we need to we also have an understanding about the connection between the components. Okay. So suppose we are going to design a torch. So we must have an idea about how we are going to connect the light and the battery and what about the switch, what kind of switch we are using, and everything we need. We need to know before we just started before the PCB designing. Okay. Next, we want to know the component package name. The package means, I'll show you. Don't be afraid. So the package name is different kind of packages available. Like I said before, these three are the resistors. These three are also resistors. It will be the same. So we need to make sure that we are using the correct packages, correct components. Okay. And before designing PCB, absolutely we need to know the basic principle of electronics. What is a resistor and how we calculate the resistor values and everything. Okay. So we are not covering basic electronics in this lecture. Okay. Or we can get into that future. And, a good to have method is we have a working prototype of in breadboard or crossboard. Okay, that's actually very helpful when designing a PCB. That actually be related to the connection between each component. Okay. Okay, thank you. So students, if you have any doubts, please feel free to ask in the middle of the presentation, no problem, because these are actually some bases we are going to learn. These are the basics and the basic building blocks. So you need to know what are these things. So I'll share the presentation to your mail. The Agil will share the PPT. Okay. So we can walk through one more. We learn about what is the PCB. This is actually PCB look like. Some components, there's some components you don't need to familiar every components. And we also learn about what the PCB made of. What are the building blocks of PCB? So you can screen, solder, substrate, and everything. Here you can see you can see this is an FR4 material. This is actually the non-conducting material in between the two copper layer. Okay. Here we only have a two layer, so we have two copper plates. Next, this is actually the copper sheet. It's actually the copper sheet is actually laminated on the top of the FR4 material. Okay, flame resistant material. That's called FR. And another thing we learned that the 2 and 4 layer PCB, that meant is how many layers are in between the substrates or the PCB. Next we learn about help PCB. Actually, the problem with the copper is copper get corrosion when is contacted with the air too much, air or water. So the solder mask will reduce the corrosion from. Okay. So next we learn about Silkscreen. What is a Silkscreen and how the Silkscreen help us. So Silkscreens actually labels to know what the compound's actually going to do or what is a compound like that. And another thing we learned about the SMD and through there is actually two kind of components in the PCB design. One is SMD, one is through. Okay. And also we learn of different kind of components. We have some, this actually through all a resistor, this some SMD resistor, and you can see there is also a wide variety of sizes in both through all and SMD resistor. Not only resistor, any kind of components like capacitor, resistor, IC, and everything. Okay. Sorry. And next we learn about symbols. Symbols actually the symbolical representative of a component. You can see this is one actually representative of the resistor value. Next we learn about packages. Packages actually is a 3D three-dimensional shape of a component. Okay, so actually help us to know what are the PCB length, breadth, and everything. Okay, footprint actually help us to uh, find the exact components and everything. Okay. Next we can check our PCB. You can see this is the solder mask, the green one. Sorry, this is solder mask. You can see these icons are the Silkscreen. You can see the white lines are Silkscreen, and you can also see some of through-hole components. These are through-hole components, and these are surface mounted components. This is a through-hole components. You can see capacitors, through-hole capacitors, and you can see SMD components here, like this one, and you can see some of they actually not soldered these components again. Okay. So actually the PCB designing actually only have two steps. One is design the schematics, another one is designing the board layout. The schematics are actually the logical connection between the components. Okay, components we already learned. Components actually the modules or the resistor capacitor is called components. So the design schematics actually the designing the connection, logical connection between the components. The board actually we are making the physical board. Okay. The third step the manufacture. Okay. The designing schematics and designing board only you get know or very well simple if you have the bill of material and you know the basics electronics or you know the connection between each component. Okay, so we can get started. So this is actually a sample design schematic design. You can see this is a microcontroller here. This is a ESP8266 microcontroller, and we have some USB to UART communication. This piece we actually designed for our community, our maker community called Makergram. I'll show you the PCB in the next section. And we have a power section, and we have some NeoPixel LEDs, actually RGB addressable LED. You can see here, and this actually the schematics. So this actually is 1, 2, 3, 4 blocks actually interconnected between. Okay. So this next one we are going to design the PCB layout. Here we only mentioning the logical connection. So the VCC will connect to this VCC connect to here. and the ground will connect to here, the data pin connect to here, and everything. And here we actually placing the components. You can see the NeoPixel LED here, right? You can see some buttons here, one, two buttons here. You can see a USB thing here. You can see a microcontroller here. You can see some kind of modules here, commands here, resistor, capacitor, everything. Okay, you can see this is our Silkscreen. Okay, so this is actually the PCB after design. This actually convert. First we design the schematics, then design the board layout, then we are converting into the manufacturing file. So here we are in the Eagle, we can also see how our PCB look like after we manufacturing. Okay, this is actually the PCB. You can see I mentioned the commands name here, LED5, LED6, and everything. I mentioned the what kind of commands are using. You can see C9, C6, the capacitor, and the LED, TX and RX LED. You can also see the resistors R1, R1, switches S1, S2, and something like that. Okay. And after we are going to manufacture the PCB. That's all. Okay. This two step. First we design schematics, designing board layout, generate manufacturer file, given to the manufacturer in India or China, which is relevant to you, and we get the manufacturer PCB. Okay. Okay. And I think there's some questions. So what is the difference between the design schematics and design board layout? Okay, that's a good question. Actually, the difference between design board and layout and schematics. Schematics actually only for the logical relation. Okay, actually first relation. Actually, we are just here. We only connecting these PCC to connect here, and these PCC connect here. That's all. We are not going to uh, uh, make the actual PCB. We are actually connecting the PCB. It's like initializing variables in programming. Okay. Here actually we align the commands. The placement of commands or the actual layout will be going to design the board. Here we are actually designing the board, the shape, the physical shape we are actually designing here. Yeah. But here we actually defining the connection between the components. Okay, I think you got clear. We are going to use Autodesk Eagle. So Autodesk Eagle can be used to generate the manufacturing files. That can be Gerber file or another kind of manufacturing PNG file. It can be used in Fab Labs across and this different kind of files. Yes, the software can generate the manufacturing file. Next, we need to select a software. Okay. After when we have everything, these kind of things, next we need to select a software. This actually different kind of software available. You can see Autodesk Eagle and it's actually free up to 2 layers and also 10 centimeter square PCB free area. I think that is fine for the most of the DI projects or the minimum project. That is fine. And next software called KiCad EDA. It's actually open source free software. We can use freely, no problem. We can also modify to our own wish. And next software called Ultium Designer. The Ultium Designer is actually the professional software used in many companies, and that's actually cost 24,000 US dollar. So 2,400 US dollar. That's actually huge. The cost is per user 2004. It's actually uh, uh, 2.5 lakh or 3 lakh or something. And another software called OrCAD. It's actually similar to Ultium Designer, but it's actually used in different kind of. And next software called ECVDA. It's actually a software provided by JLC PCB. JLC PCB. When you watch any YouTube maker videos, you can see many JLC PCB sponsoring many YouTube videos. So JLC PCB is a Chinese manufacturer who make PCBs. So they actually made a software called ECVDA. So you don't need to install a PCB designing software in your computer. You can use like Facebook or Instagram or something like that. You can just need to log into the web page. You can design your PCB. Okay. I got another question. What does number of layer PCB actually signify when I want to design a PCB? Actually, number of layers is means you can see this in here. We have two layer PCB. That means these have a one layer, these have a one layer. So we can also interconnect it between this. This how many copper sheet in between the substance equal to how many layers we have. Why is significantly you need to consider that if you want to reduce the size of PCB, you need to more kind of layers. Okay, so we'll learn about more about here and use some complex things. We need to number of layers is better quality. No, actually number of layers not related to quality, but it will reduce the size of PCB. That's all. Okay. Yeah, and the software we are using Autodesk Eagle. So I confirm it. I am very much comfortable with the Autodesk Eagle and the easy KiCad. And but when I learned, I think Eagle is providing very much and very small learning curve, very easy to learn. Beginners and expert, everyone can learn, no problem. So that's why I choose the Eagle for this webinar. So you can read a small introduction. To design a PCB will be Autodesk Eagle software. Next section. Autodesk Eagle is a CAD program. CAD is computer aided designing software to make PCBs. So the software is free for two-sided boards up to 80 centimeter. So we can only use two layers in the free version of Eagle. So if you purchase the Eagle, you can use 60 layers, 30 layers, okay, bigger than that. And you can also go into 80 centimeters square PCB. That actually huge when come to PCB designing. Okay. Okay. Next, we are going to design schematics. So we are going to actually going through the designing process. So anyone have any suggestion? So what we need to design or something? Or I can choose design a thermostat. You want to, or you can suggest any kind of PCB or something like that. Okay. So actually, I think no one have any suggestion. Okay. First, we are going to design a digital thermostat. So the idea about the project is the project able to display the temperature and humidity on LCD. I think you are familiar with the Arduino. It's very simple project, right? With Arduino and breadboard. But we are going to make it as a PCB, a single board PCB. Okay. And we also need another feature. It will need to some alarm function when the temperature is too high. It's depend on the user. Okay. And we can check that what are the commands we need. The temperature we need a temperature sensor. So temperature sensor is a DHT, digital humidity sensor. Okay. Next, to display the temperature and humidity, we need an LCD module. Okay, that's okay. Next, to alarm the user, we need a buzzer. Okay. To work with a day, we need some battery. Yeah, we need a battery. We can use 9-volt battery. Next, we need a microcontroller. So we can choose a 80 mega 328p. I think you're familiar with it when we are using Arduino. So Arduino is actually an ecosystem. There are actually different kind of boards. Particularly Arduino Uno is based on 80 mega 328p microcontroller. Okay. So this PCB we are going to manufacture. Okay. So we can just start it. First, you need to download the Eagle software. You can get the Eagle software here. Autodesk. Yeah. Actually free downloadable. I said 2 layer and 80 centimeter square is very free. I can see include with a fusion data. The free download is a limited version for OBS include 2 schematic sheets and 2 signal layers. Okay, that's good. If you can download, depending on what version of computer you are using, Windows, Mac, or Linux, which depends on your operating system. So I already have installed on my computer. You can see here. So I'm going to open the software. So keep in mind, we are going to design the schematics. First, we are going to design the schematics. Then we are going to design the layout. We are going to generate manufacture. And also, I mentioned that it's good to have a breadboard prototype. Okay. So we can see I already have the prototype made. This one. There's a link here. It's open here. So this is our project documentation. I'll share the after the webinar. You can see we are going to make a temperature digital thermostat. So this is our sensor. So the sensor will send the temperature data into the microcontroller, in case our Arduino Uno, and it will display into an LCD. Okay, that's fine. So these things we need. So this is our DHD sensor, and this is our LCD module, and some algorithm. We are not going to the coding part. I hope everyone will know that. And we actually are using I2C module. Actually, normally when we are using an LCD module, we need to use actually the 16:2 LCD. We have 2 modes. One is 8-bit mode and one is 4-bit mode. In 8-bit mode, we need to use 8 pins. For the 4-bit mode, we only need 4 pins. And also there is another option, we can use I2C. I2C is the integrated circuit. It's actually communication developed by Philips company. And this actually we only need 2 pins to communicate. One is CSCL, serial clock, another is SDA, serial data. Okay. And these are our schematics. We developed our firmware here, and you can see we just checked our LCD. This is actually the process of building prototype. Okay, I just next we are connecting the DHD sensor. First, we already tested the DHD sensor alone. We get the value, humidity, and temperature in the serial monitor. And we next we tested the LCD display. And finally, we are going to merge the 2 codes, the DHD code and the LCD code together. And finally, we get the humidity 74, like that, temperature. This. And next, we are going to convert this breadboard prototype into our actual PCB. Okay. If you have any doubts, please let me know. Hello. I guess it's audible, right? I hope it's audible.
No problem.
Okay, thank you. Okay, so we are going to convert this to here. So you can see uh, uh, the connections here. This is actually the connections. So I already know because I made this documentation. Okay. So first, this our okay. We are going to this actually the legal EDA software. So we first need to design create a new project for that file, new project. So we are going to digital thermo. I just gave it digital thermo. Okay, and see this is our project file. Next, I'm going to create a schematics. Okay, actually in the PCB, I already said there is 2 main part. One is schematics, one is designing the board. First, we are going to design the schematics. Next, we are going to design the board. Okay. So this is our work area. You can see. So I'll give an introduction about the different kind of tools. This is actually command prompt. We can add some commands here. And this is actually a toolbar. You can get some toolbars here also. You can see different kind of tools like move tool, copy tool, delete tool, add design block, add part, port, net, AB, and different kind of tools. Okay, don't be bother about that. You just need get started with some basic tool first, then you can master everything. Sorry. So for the project, what we need is we need an Arduino. So make sure that we are not using an Arduino. Okay. So the Arduino, I'll give an example. Yeah, I can. Okay. Arduino. Yeah. So you can see Arduino is a microcontroller board based on 80 mega 3280. Okay. So we are not for the PCB. We don't need to use the Arduino itself because they actually there is lot of pins I am not using. You can see these pins I am not using. These pins I am you not using. You can see the IO reference, reset. These pins I am not using. This USB I am not using. The power socket I am not using. There is actually so many unused part. So this is actually waste of resource, right? So I'm not using any of these pins on, and I think this size is very bulky. Actually, this will be the product. So no one will going to buy this product, right? This kind of jumbers and everything. So we need to make sure that we are making our product in. So when we schematic, so we need to make an Arduino Uno minimum schematics. Minimum diagram. That means what are the minimum components to work with an Arduino Uno. So you can see here. Another parts. So this will be 80 mega 328p, and also I'll check 80 mega 328p data sheet for that. Okay. Meanwhile, we can check. We need an 60 megahertz crystal, and we need 2 picofarad capacitors for the clock, and we need a reset resistors, and that's all. That's all we need. We need a crystal. We need a resistor. That's all. So how we know the minimum components? We can check the data sheet actually. So I'll show the data sheet. We need a complete data sheet. Yes. Loading. Okay. So you can get the every. It's actually the full details of the microcontroller. You can see how many pages. 294 pages. That's huge. Actually, everything is mentioned. It's a 8-bit microcontroller based on a REST architecture, reducing second set computer. 131 instructions, 32 jumper registers and everything. Up to 30 means at 60 megahertz clock. So Arduino is actually using the 60 megahertz clock. You can see some pin. This actually the Arduino comes with a different kind of layout. These are the TQFU kind of layout. But currently we are using the throughout component. Okay. You can see this VCC for the supply voltage, GND for the ground. You can see the uh, you can see the port B. Here we are going to connect the uh, crystal oscillator, the clock, the 60 megahertz clock, and everything mentioned in the data sheet. Okay, take a look. So first we need what? We need a microcontroller. We need 80 mega 320 controller. Sorry. To add a component, we have different ways. One is we can here we can. I don't know. I didn't use these tools. Yeah, you can use Control Shift here, add, and here you can get this window. And also you can come to here. You can click there. Can also. And one of the I mostly use the command line. You can just click add, click enter, it will pop up a window. So here you can select different kind of commands. Like for the resistor capacitor, there is a library called RCL. This is for resistor, capacitor, inductor. Okay, we have capacitor, different kind of capacitor. You can see with it. This is actually the symbolic representative, and this is actually the footprint. Okay, that we learned before. You can also see some kind of 3D design. Yeah. Yeah. Some packages have some 3D designs. Okay, this one. Okay, but currently we need a 80 mega 320 controller. 80 mega. Yeah, here we have a 80 mega 320. This actually 80 mega 320, and the package name is DIL28. So we need to check DIL20. Okay, so DIL20 actually kind of this package. Dueling package is need this kind of. We are going to use this kind. There's another called QFN. This one. There's actually different kind of microcontroller package. Here you can see they mentioned TQFP, this package also. Okay, but currently we are using DIL28 package. Okay, fine. So we need to click here. So the microcontroller will be here. That's all. You can use many of copies. Yeah. You can use your mouse scroll wheel to add 1, 2, 3, 4 microcontroller. But currently we only need one. Okay, that's all. Next, here you can see we need to connect an oscillator, a clock, right? For that, again we click add, and for that we need to create a clock. So we just crystal, we check crystal and check if there is any crystal or something. This is actually default library. Yeah, here can crystal, okay? But the problem is, like I said, there is actually different kind of crystals. So we are going to use the 2-pin crystal. Actually, the difference between these actually the through hole components. You can see this actually drilling hole, and this one is for a surface mounted. There is no hole. Okay, actually many kind of clock or crystals. Actually, the crystal package is over. What we need is we need to use something like that, but not that one. We can check these two. So if you're confusion about how I know about these things, because I already designed and I already completed the prototype using PCB, so I know how to use each of the components. I think you're familiar with these kind of clocks and everything. Okay, this is actually we need. Okay, can check HC49 UV. Okay. Okay, this kind. Okay. So this thing we need. This actually used in the Arduino Uno. And see here. And the funny things about Arduino is actually I need to okay. The funny thing about Arduino is this the crystal for this is actually the clock. Actually, this clock is not related to this one. This clock is actually related to this controller. This is actually 80 mega 32U4. For this microcontroller, this is the main microcontroller. For this, we are using this clock. This actually you can see a assembly version of clock. You can see also capacitor here. Here, for this circuit actually a programmer circuit. It's actually converting the USB signal to ISP, circuit serial programmer. Fine. So we need to select this capacitor. Okay, fine. To rotate, you can click right button of your mouse. Okay. And also you can use rotate. can move. Okay, fine. And next we need what we need. We can check the minimum circuit. We need two capacitor and resistor. This is not good. Yeah, we getting yeah. It's actually a good one. We already got a crystal. We need to use two capacitor. Okay. So once more we click add. We need to add capacitor. For the capacitor, we can check the RCL package and the RCL here. For the capacitor, we can use SMD or something. There's two type of package for the EU, European Union, and one is US. Two kind of capacitor model. The European doesn't have any polarity because polarity means there is no plus or minus signals. We can use right away. You can see different kind of capacitor here. Many kind of capacitor. This we need the capacitor. The footprint is this. Yeah. This one. Okay, sorry. Okay. Anyway, we are going to use this footprint. So we are going to place it here, and we want for here. And we also need one capacitor for to filter the DC signals, yeah, to avoid the fluctuations. Next we need, I think we need a resistor to pull up, right? Yes, we need a resistor to pull up. Why this need is, you can check the data sheet. I can see the, here I can see the a lower level pin, a lower level up. That means this pin is, if this pin doesn't have any voltage, or that pin is connected to ground, the microcontroller will be going to reset. Reset means the code will be again and again work. Okay, so we don't need to that happen. We don't need to reset the microcontroller. So we need to make sure that this pin have a high voltage. That we call. We can also mention that we are going to make it as a pull up. So we need to use the resistor, different kind of capacitor. So we are using this one. It's a O2 O4 package. You can check on the internet. O2 O2 package. Section. So these are our O2 and O1 package. You can see here. This will be the resistor. Okay. You can also see the 3D package here. So we are going to add this also here. Okay. So currently we have the minimum circuit. You can see we have a microcontroller, we have a capacitor, and we have some capacitor, and we have a clock. Next, we need to connect each of them. For that, we need to use a tool called net. Okay. For the net, we can connect here. That's all. And we can. Okay. Also make sure please save your work when you are using. So I SCH schematics. Okay. Next, I need to pull up the reset pin so that I place here. Another thing we need to make sure that we need to connect some kind of ground and VCC. For that, we are going to connect the ground to the VCC. Actually, the problem is we have many components that require the VCC and the ground, the power lines, and we don't need to connect everything to like just connecting here, disconnecting here, and something like that. That's another thing called labeling. We can label the components. Okay, so it will automatically connect in the board layout. For that, we can also find another component called and search for the VCC and see the VCC here. Okay, I'll select the VCC. Next, I need a GND ground. This one is I interested. I use a ground pin. Okay, that's all. We're connecting the yes. So it means I'm using the next segment N6 to VCC. Yes, fine. Yes. Okay. So it will be connected. And I think we can better beat these because I'm more conscious about the design. Okay. So we can. Okay, that's fine. Next, we can check the schematics. You can see this one is actually connected to 5 volt. So we can. Another good thing is we can copy the schematics. I can copy right now. No problem. And select Control C, then Control V. Strange. Check one more. Control C. Actually, copy the component from there. So actually, that means it's actually connected with the VCC to this VCC. Okay. You can make sure you can check that with using the show button. If you click here, you can feel the color will be changed. Right? I think using the you only can find the color change in VCC. All the BCC connector will be just bit of glow green color. Okay. Next, we need to connect to the ground here. So that we can copy this ground. So that just select it, copy and paste. Okay, that's all. And I think I need to rotate this would be better. Just for the beauty. Okay, that's all. So what actually we did is we made an Arduino. This is actually the Arduino board. Okay, that's all. Next, we need to add some kind of filter circuit. This actually helps us to remove the AC signals between the in between the AC in the VCC and ground. For that, it's actually already connected to VCC, so we just need to connect. So we already found a filter. Next thing we need to make sure that we need to add the value for the each components. What kind of value are you? So you can check here they are using 10K capacitor, so we can get 10K will be 10K. For that, we are need 22 picofarad. So click the corner here and 10 picofarad. Then F here also value 10 here. Okay, that's fine. Here we are going to 60 megahertz. Okay, that's fine. I think that's all. That's fine. Right now we have the Arduino. We have the Arduino. Next, we need to connect the DHT sensor and the LCD. Okay, right. The first we can connect the LCD module. The LCD module only required for connection. That is SDA, SCCL, VCC, and ground. So we can get an header pins. We don't need to directly solder the LCD into our PCB. We just make some headers. Okay, so we can snap it our PCB together. For that, we can make a pin like this one in our PCB. Okay, for that we need to add pin. We need to check some pin header. Yeah, we got some pin header. For that, we needed 4 pin, right? 1 into 4. Okay, we need these kind of pins so we can directly solder our controller. Check with some email. It will be fine. Okay. So we pasting this here. Okay. So first, what are the pins? SDA, SCCL, VCC, ground. Okay. So you can see the SCCL and SDA here. So the SCCL is on the top. Hello? 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 Sorry, not clear. Can you text? Okay, it's not clear. Yeah. I made a big mistake. Thanks for mentioning. Actually, this actually here to here. This ground is here to ground. Yeah. Thank to Tarun. Actually, it's my mistake. Sorry for that. I need to delete the commands. Okay. 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 Now it's fine. Thank you. So make sure that. Okay. Now it's fine. Thank you, Tarun, for the feedback. Next, do you have any other? Okay. Thank you also, Abdul and Tarun. So next, we need to connect the I2C pins. For that, we need to use the SDA and SCCL. Also, it's better to choose like it as SCCL on the top, SDA on the right. So that will be great. SCCL on the top, right? So we can actually I don't like these kind of design, so we can one thing is we can swap the pins or we can label these two. Another thing called labeling, like we do here, we are using actually called labeling, and we can also label another method called here label. For that, just click here, but you can see like this. For to get an actual annotation, click here. So you get something like that. Also reduce some size. Okay, this will be fine. Click here. Next, we need to make a label name. So here we are going to take SDA. So the name will be SDA. Here we are going to get SCCL. That's fine. And here we need one for the SCCL, SDA, VCC, and ground. That's all, right? Yeah, CCL, VCC, ground. Sorry. For that, we need another labels. We're going to label something like this. So you can use your right button of your mouse to rotate. Okay. Okay. And for here, we are not going to use label. We are using the ground and VCC components. Okay. Yeah, we are going to rename it to SCL. So the both SCL will be interconnected. These will be interconnected. Okay. So you can use the show button and click. You can change the color difference. You feel the color difference. Okay. Next, we need to change these two name to SDA. Fine. Next, we are going to power using the VC. First, we need a VCC. So this time I'm going to not going to wrong. Okay, copy. We can paste it to here. Okay, and also we can put these two somewhere. Next, we need ground. Where is that? Okay. What is that? Okay. Okay, we just connected the VCC and here, this is our the display port. Okay. Next, we need to use the DHD. DHD actually have 4 pins, but we are going to use only 3 pins. One is this one is VCC, and this one is D data pin, and this one is a ground pin. Okay. Anyway, we can add the 4 pin, so we can mount it on your our PCB directly. Okay. And here the first pin will.
Okay.
Okay. Question. Okay, fine.
Yeah.
Can you recap about the overall schematic design? Okay, I'll recap after the PCB schematic file. That's fine, right? I'll recap after the complete design. Next, we are going to, and also we are going to design a small, simple basic LED after the complex one. Okay. Sorry. So here our first pin will be the VCC pin. We know that by DHT11, this sensor we are going to use. Can see this is the pinout. You can see first we need VCC data, no connection, ground. Okay, first the VCC. So for the VCC, we can copy the this two. Yeah, directly connected, no problem. And next pin we need a data pin. For the data pin we are using this actually the actual port. This in a microcontroller, these actually different kind of port. TD, port D, port D2, D3, D4, and also port B, B1, B2, B3, and everything, and also port C. Okay, so you can see this port can capable of ADC. That means analog digital conversion. So in here, the Arduino Uno, we actually utilizing the uh, ADC port for the analog pins and the digital port for the digital things. Okay, so this actually port D actually the digital ports, and actually these are also digital ports, but this actually capable of analog too. So we can use D5 because I just used it because this is actually very nearest to me. And the 3 we are not going to connect the 3 pin because there are no connection. Next we are going to use ground. Ground we can copy from here. Okay, that's all. And we don't need to. Okay, that's all. So we just completed our. We also need to make sure to name it. intermediate value and call LCD I2C. I2C. It's actually the 8 LCD I2C. We can another one is we can value it or we can rename it. We can call it DHT11. Okay. Sorry. That's D2 humidity temperature for the here. Don't need any value. We can just make sure that to get the properties, you can see there's a cross section. Every commands have a cross section. That's actually the control point. Okay. Here we can see cross section. We can see some cross section. So that's actually you can get the selection from here also. No, but when you click here, the magic will happen. Next, LCD I2C. Actually fine. Okay, that's fine. So next, also make sure that we are going to make a product, right? So how we are going to power it? There is actually no port, so we need to add more power pins. For that, I can use. I was planning to use. We can use 9-volt battery. Okay, I'm going to use 9-volt battery. But the problem is the Arduino is only capable of doing how much current? Oh, we are doing webinar. Okay, next. Sorry, something about my computer. Happen. Refresh the window. Can see the voltage should be the supply voltage is 2.5 voltage. Okay, so but here we are planning to use a 9-volt battery, so we need some kind of voltage regulator. So I think we can use voltage regulator. There's a one voltage regulator called LM1117. It's a very good voltage regulator. We can use that. So it is actually capable of converting 9 volt to 3.3 or 5 volt. It's actually an adjustable voltage regulator. So we can add that in here. But this voltage regulator will be not available here. Yeah, I found one. So we can find different kind of voltage regulator. So we are going to use a specific one that is actually called SSOT. SSOT 23. SOT 23. Sorry. SOT 3 too much smaller. I was planning to use 3.3. 3.3 is available amount. Yeah. Uh, yeah, this one. This one is we are going to. This is actually a surface mounted devices. Okay, this one. We are not going to use any whole commands today. Check it's not available. Actually, this is not available here. But there is an LM1137. I think we can use that too. We can check. Three terminal just negative regulator, so we don't need that. Okay, we are planning to use LM1117. Next, I'll show you how we can convert, how we can add a library from in web to our PCB schematic. Okay, since the LM1117 is not available here, it's not available, right? LM17 is available here, not 111, right? It's not available, right? Please, LM1117 is not available. So we are going to LM1117 Eagle library. Okay. So you can download the Eagle show library or something like that. Yeah. The best thing here we can do is GitHub. GitHub is the best friend. You can also design your own components from here. Here you can design your own components and library and everything. But today we are not going to that because that's very much complex. So here we are going to download the lm117.lbr. Okay. Okay. So I'm going to copy that into my Eagle Fire. Yeah, documents. Where is that? Libraries. LM117. Okay, fine. Next, I need to add it on our software. For that, click Add. Then you can see Library Manager. Open that. In use, then browse the error. So you can see LM117 here. You can see LM117 is added. This is actually different kind of 800 milliampere low dropout regulator available in 1.8 volt, 3.5, 2.85, 3.7, 5 volt. We need a 5 volt. And next we need to check is available. Yeah, it's come here, right? It's actually different kind of LM117 here also. Yeah, this one. This is this thing we are going to use. So yeah, this thing. Okay. So we are going to add this thing here. Yeah. But before using that, we need to check the data sheet. So you can get the typical application pinouts. Here they're using the Win actually. The LM terminals can handle up to 28 volt and it can provide 5 volt. Okay. And we also need to use two type capacitor for decoupling, filtering, C1 and C2. The 0.1 microfarad in input and 1 microfarad in output. Okay. We can also use a variable resistor to control the adjustable the power supply, output power supply. In this case, we don't need that. There's an equation how we can come the transient response. We don't need that right now, so we can go ahead. Anyway, we need two capacitor. For that, we can copy capacitor from here. Capacity here. It's not happened. You can place it here and can place it here also. Place it here. You can see why this two output array. That means actually these pins. This is SOT223. This is actually interconnected. This pin and this pin is actually interconnected. Okay, that's why it's our two terminal. So next we are going to connect these two. Like this. And ground. Right? Okay, that's fine. For that, 0.1 microfarad will be fine. So we are going to point 1 microfarad capacitor here. Here also. 0.1 microfarad. That should be fine. Next, we need to add some ground. We need a ground here. Yes. Yes, we need to connect to the ground so that two ground will be interconnected together. Also, we don't need to complex. We can also use this line to connect here. I guess like this one, this way. Next, we need to connect the VCC. Okay, so we just did our power supply unit also. So this will be get to adapter. So we can use some kind of 9 volt adapter, 9 volt battery adapter. So we can use something like that also. These thing, not this thing. We can use not this this kind of 2.5 ohm jack. Uh, uh, yeah, yeah, this thing. So we can use these be connected to these header pins, and we can connect the battery to here. Okay, fine. And we get a 9 volt, 5 volt here. Okay. Okay, cool. Next, we need to add. What is we need to add? There is some other things you can see: a ground, a reference, a VCC, and everything. Actually, we don't need to use that right now because that actually depends on the different kind of reference voltages. You can see ABC is the supply voltage pin for the analog to digital converter. Currently, we are not using any kind of analog to digital converter. So this will be fine. Okay. And ARF. We don't use any AD. And one more thing. Actually, for this project, 80 mega 380 is actually kind of overkilling. Okay, because we are actually wasting many much resources. We are not using any of these pins. These pins actually only we can use some microcontroller like 80 tiny 80 tiny 45 or something like that. That actually we only need for this kind of project. Okay, so make sure that when using PCB designing, the most critical thing is select for appropriate components. Select appropriate components because single element will cost you more dollar when we manufacturing 1,000, 10,000, 100,000 PCB. Okay, so make sure that only use the components you need. Okay. Okay, we are not using this kind of, we are not using SDK. And another thing, if you want to program it later, we want to, how we are planning to program it? We didn't think about it, right? For that, we are going to use some called ISP header. In Arduino, you can see in Arduino, there's another pin called this kind of pin. This ICSP, in circuit serial programmer. I'll show you. Here. This is ICSP in circuit serial program. So this pin we can program this microcontroller. Okay. Actually, what is this do is this is receive the USB signal and convert it to ISP signal and pass to the microcontroller. This is how it's happening. But currently we are only using this microcontroller only. So we need to add some kind of ICSP pin, and we can program our Arduino using another Arduino. Okay. For that, we need to add ISP header here. And actually, this pins are 1, 2, 3, 4 into 2. Sorry, 3 into 2 and 2 into 3. In head. You got the idea, right? To program our board. 2 into 3. 2 into 3. Yes, this will be fine. Okay. So here, and also make sure that there is some actually, there is a standard layout of ICSP header. ICSP. So this is a standard header. First MISO, SCK, RSP, then VCC, MOSI, ground. Okay, so we're going to make like that. First the MISO, MISO. Next we are going to use SCK. VCC, and we are going to use. Okay, fine. Next, we need to add the. I think you already know how we are going to connect the components, right? We are going to connect. First, we are going to connect the VCC and ground. So, like I do, you can just copy paste the components from here. Where does the VCC come from? On the top. We already have the ground. So this will connect to the ground. Next, we need the VCC. We don't need that much wire. Okay. Next, we need there's a MOSI pin, so we can connect the MOSI from actually. Can see this the MOSI, and we also have a MISO. MISO. Can see here. So next we need a SCK. You can see the SCK here. Okay. The next we need a reset pin. So here is a reset pin. So actually we don't have any reset pin currently. So we are going to make a labeling. So you can click here. Name it. Reset. Okay, fine. Next we are already using that tool. We will send that. So the reset, this reset and reset will be internally connected. That's fine. I think we currently have most of our components, right? So everything will be perfect, no problem. And also, this is actually not a connection. For the connection, we need to add some kind of this. Okay? So, so we don't need connection there. Fine. Anyone have any doubts? Next, we need to add some documentation is always important. So we need to add some kind of frame. For that, you can set for the frame. There's different kind of frame. So I choose this one. This one is a little bit smaller. So I choose bigger. Yeah. We are going to name it as a can click. Okay. So this actually we completed our PCB schematics. If you have any doubts, please ask me. We only have. I think we can go up to 5.5. Can you check? Can you explain how to get the sensor? How to get that sensor on LCD? We'll just change the name GP1 to make them as LCD. No, no, no. Actually, I just name it for myself. Actually, I was planning to use. Let me check. So I was planning to use like this one. So this is our board. So we add an LCD. Our LCD will be like this one. Our main board will be here, and the LCD will be here. Okay. Actually, this will not convert the board to LCD. We are actually just using the pins only. Okay. So we can connect our LCD directly to in here. And here also, we only use the pins, not the LCD module itself. We don't need the LCD module. We can add the LCD module. I think it will be here. Check there is some LCD or something like that. No, there is no LCD, but you can check there is some segment displays here. Different kind of LCD. Check. The LCD might be like this one when we are using. We need to use the 16 pins, but currently we are not using because we are only using the I2C. Okay, fine. The doubt is clear. Okay, thank you. I just name it to know the PCB when I converting the board. Okay, fine. Next, we can go to the schematic, the board layout. Okay, everything is fine, right? We added the minimum Arduino circuit. Next, we added the LCD and the DHT pin header, not the module pin header. And we also added the ICSP pin header to program algorithm. ICSP. ICSP means in circuit serial programmer. We can program the microcontroller using the MISO, MOSI SCK, MOSI master out slave in, MISO master and slave out, serial clock, and VCC ground. That's all. Okay, next we are going to design the actual PCB. Okay. For that, click the generate switch to board. So create from schematics. Yes, please. Okay. So this is actually the actual components. You can see this is actually our microcontroller. So if we use the SMD version, this will be another look like. I'll show you. Add 80 mega 320, right? 80 mega. Sorry, where we get the 80 mega on the top, right? 80 mega 320. They have many kind of versions here. Not SMD. Oh, no. Actually, actually I do here. 80 mega 16 for anyway, I check the 60. Actually, yeah, this. If I use these kind of code, you can see we can find any difference between this shape and this shape. But when I save and back to schematics, you can see the difference, right? Is the difference actually. So make sure that you need to select the exact schematics. I'm going to delete it. Right? So I get the board. Next, also make sure this is our work area. We need to make sure that to decrease just in this space. You can see the milli size here, and this is a 0, 0. You can also draw circles and other polygons here using this one. Okay, no problem. Next, we need to place our components actually. Actually, we need a little more bigger. Okay. Yeah, that should be fine. We need to go into connect different kind of components. We need to use the regulator, voltage regulator, the I2C pin header, the DHT pin header here. And the power connector, the 9-volt adapter. This may be the reset thing, so we can put here. This is actually very time-consuming process. Most of the please also make sure that you need to make sure to keep the crystal very near to the microcontroller, because the crystal is actually providing the clock for the entire operations. So if it will far away, there's some induced and will or something like that in the lines. So the overall microcontroller performance will be slow and will not work properly. And these show the capacitor. We can arrange like this. And also, I think I just forget to connect this thing to the ground. Should I connect it, right? I can see anything from here. Actually, I just can see there's some problems here between. It's actually not connected to the ground. It's actually a program or problem. Let's check once more. It's actually a bug. Let me check after the. Ah, you can find some many problems here. The C3 is not connected to any of the pins. C3, C3, yeah. Actually, this is connected but not connected. This is connected but ground is not connected. Yeah, it's now connected. And I think the same problem will be here too. Okay, now it's fine, right? So connected, and this one is also connected. Okay, great. Next, we are going to C4. Why we need C4 and C4? It's for the uh, regulator, right? So we can place it near the regulator. Yeah. We also make sure that rotate, so we'll get nice and place the commands. Okay, that's all. Next, so this is actually very time-consuming process in PCB designing. This actually also depends on how our product look like. This will be the physical one. Next, to make it the actual copper pad, we can use the root airware. We need to connect the roots. Before that, we need to make sure some design rules. Okay, so I'll check. See, the C Studio have some kind of PCB manufacturing services. Uh, Fusion is called Fusion. There's many kind of PCB the manufacturers, JLC, PCB, and everything. Here you can see the specifications, the manufacturer specification, Fusion PCB specification. Okay, that. So here they are telling that they can minimum size the board will be 10 millimeter. So 5 millimeter board they can make. Okay, maximum size is 50 centimeter. The tolerance will be plus minus 0.2 mm. The minimum board will be 5 pieces we need to order. The maximum will be 8,000 order. Okay. And the layers, board thicknesses are different kind of layers. You can see the 16 layers, the thickness, the tolerance. Yeah. And also the price, spacing, and the width. You can see, so everything is mils means thousands of inch. The minimum trace width will be 60 mil. Okay, that's we need. Here you can find the not in the option. Edit. You can see the design rules. Here we need to make some rules. You can see what are the minimum trace width the 6. So I give 6 mil is fine, right? 6 mil is fine. Anyway, I'm going to take as a 10. Yeah, the pad will be 10, every wire will be 10, something like that. 10, 10 and SMD. Yeah, we are using one SMD, right? The voltage regulator. Different signals 10. The 6 is okay, but I just gave into as a 10, right? And the difference between the copper, the 40 millis is fine. You can find here. The 12 mil is the good, so I give it a 40 mil, so it's fine. The drill hole is a 60 mil, so um, annual ring, that's called annual ring. So 0.1 mm. Okay, that's also fine. 6 mm. The size is minimum width, so we are going to as a 10. Everything is fine. Now we can draw it. Can also give the 16. So for some situation like the power adapter and everything, we just need to make it more. Some compounds need to draw more current, so they actually need more copper. So for that, we can click here. We can take it to 20. You can see the difference between these. Okay, so we just need 10 right now. So we're just using 10. So I just connected these two. Next, I want to connect the ICSP pins. For that, can you see? Can you see that? Also, if you want to use two-layer PCB, we can click here, and we can click the via here, like that. Here, and from here, you can click the via. Can click the bottom bar. Can click the bottom bar. Then the blue color is actually the second layer PCB. Okay, so the via actually connecting the two PCB. I'll show you the PCB via. Let's wait. PCB. Yeah. So this is the best example. This actually how many layer? 1, 2, 3, 4, 5 layer PCB. So actually the interconnection between two layers, we are using something called these tunnels. This is called vias, VIA. Okay. Okay, fine. So here we don't need via here, so I just showcase how we can use the via. I need to remove the via. Okay, next. So here the result. It's actually very time consuming process. For actually we need to use the manual uh, uh, routing. So I'll give you some tip, not a tip. There is a trick called auto routing. To delete everything, make sure that you don't use the delete, because if we are using delete, the component will be deleted. We don't need that. We actually need to delete the connection, right? If you want to delete the component, you need to go to the schematics and delete a component. For here, we are using a tool called ripup. So ripup can remove the connections. To remove all the connections, you can use ripup semicolon. Will remove all the connection. And also make sure that for next, I will show you how we can use the uh, auto routing function. Okay. For that, auto router. Yes. Here you can see different kind of actually the PCB support 60 layer of PCB, but currently we only using one layer. We can try it on one layer. We can first try it on two layer. Automatically connect. You can see. Yeah. Yeah, it's done. Our PCB is completed. Okay, it's automatically connected. No need to do anything. Let's check. We can check. Uh, but the best thing is use manual routing, because the computer generated one is not efficient. The wires will be something like, yeah, this is 1 point. 1.5. 1 point. 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 That's a 0.1 microfarad, right? And the voltage regulator you have connected to 0. That's not a problem. Actually, I think you said this one, right? Yeah. For this, actually, this is actually for the Silkscreen to know the humans, not for the computers. Okay, so we can name it whatever we want to do. Okay. Anyway, you just mentioned, so I can change the value to 0. So I can make sure that I can also make that to name it like 0.1 microfarad, and I can also connect to the 1 microfarad. That's no problem. But this is a problem when we are using simulations. The eagle is supporting some kind of PCB simulation, then it might be a problem. But currently, it's not a problem. Okay. So I think your issue is solved, right, Shakti Priya? Just for the annotation. That's all. We can try another router. Yeah, we are using only using the top layer only. Okay. Okay. Yeah. There is actually different kind of iterations, different kind of models. You can select one. I think this one looks good. I can select this one. This one. This one is fine. Okay. I use this one. Okay. Next, we can move the commands. So this will have. You can see the manufacturer file here. How to give custom shape for PCB? Okay. For the custom shape is actually another big topic. We can use something. I'll show you after this section. Okay. You can actually draw something called this one. There's some basic draw shapes and see dimensions. You can use that too. Much. I'm not using that right now. This is a little bit so okay. So this is our selected one. You can see our PCB. You can see we for the preview they're using the green color solder mask and white color silk screen. You can see LCD I2C. So the port will be available here, and we just connect the LCD to here. You can see different kind of combustion. You can see this is a resistor, this is a resistor, this is a one SMD voltage regulator, and here we are going to connect the 9-volt adapter. This is ICSP adapter and everything. Okay, this is the bottom side. Nothing. Okay. And next, another one thing is it's better to have a ground plane. It's actually better to have a stability. Uh, Actually, what is doing is they actually milling the traces from the copper clad. Actually, they are actually milling the traces. So here you can see they need to mill everything, right? They need to mill everything from here. Actually, this is a copper sheet. They are actually going to mill everything, and only the balance will be the traces. So we can save the process from adding some kind of ground plane. It also very good to our to improve the stability of our PCB. For that, I just need to remove all the ground plane. I'm going to remove the ground planes first. That's also fine, right? So I'm going to make a polygon. Okay. Sorry. Okay. Kind of problems here.
Salman, there is one more question.
Okay, let me check.
Hello, Salman.
Also, how to export a completed PCB design to Fusion 360 or another software or design software? Yeah, I'll give you. Actually, these two options are, uh, are related. And what the advantage of ground fill over copper fill? So actually, it will reduce the EMF and it will actually uh, give some stability to the PCB. Noise reduction. So I just draw a ground plane, then I just give it GND, and next I need to give the RASNet. So there's some problems. Check. Sorry, this is very slow. So I'm just making one more auto route. So here we are only using auto route to make sure that everything is work very fast. And that's all. Yeah, just using this one. No problem. So yeah. So we just made a ground plane. Okay. So now you can see the PCB. Yeah. So the one thing is the ground plane will be help us to get a more stability and avoid some noise problem issues, electrical noise. Okay. You can see, and also it will help you to manufacture. They only need to remove the copper here, and you can see here also. Okay. So this will be. And next question, how to make a different shape of PCB. Okay. For that, I'll show you. I think if you have any doubts, actually we just designed our PCB and everything. Next, we just need to create the CAM process. So it will actually generate the bill of material that we need to give for the PCB assembly. And also give bottom profile, the profile for the cutting the layout, solder mask, bottom and everything. We just need to do the process job. I just gave it desktop. You can see the cam out different kind of assembly. The assembly file is here. Okay. Bill of materials here. Drill files here. Gerber files here. You can see the Gerber file here and everything. Okay. You can also see the different kind of layers. Top layer, bottom layer. I'll remove all the layers. Sorry. I'll disable all the layers. Okay. This will be the top layer. This will be the bottom layer. Add via. We don't have any via because we only use one. Unrouted. Replace. The origin, the names, the value, stop, and everything. Okay. This is our PCB. Fine. Okay, next, if anyone have any doubts, actually we completed our, we just designed our schematics. Yes, we just designed our board layout. We generated a manufacturing file, and next stage is manufacturing. Usually, okay. Anyone have any doubts?
Yeah, one more person texted there.
Okay, sir, how to add custom logos in the PCB Silkscreen? Okay, that's a good question. One thing we can add as a normally people do is, I'll show you. Actually, the PCB Silkscreen we can use. You can import some kind of DXF files here. Okay, you need to design the DXF, and you can convert it to and import the DXF into the PCB design. So you can make designs like this one. Where is my PCB? Like this one. Okay, I was exporter from the DXF. Next option, how to make this kind of shapes, right? So for that, the good thing is about Eagle is actually associated with the Fusion 360. I'm not associated. It's actually owned by the Autodesk. The Autodesk actually built with on the Fusion 360. So we can export the design PCB design to Fusion 360. Just need to click the Fusion 360 file here. Create a new Fusion 360 file. Yes. Make sure that you need to use the same username and password for the Fusion 360 and Eagle. So I need to create a new file. So I just create my file. Yeah, then click. Actually, I need to create a folder. Cisco. Okay, I'm going to NC folder. Cisco. Okay, next. I need to push the alt command. And there is some warnings because the C1, C2, C3, C4 doesn't have any 3D package. That means this doesn't have any these kind of 3D dimensional shape. Only DHT1 and ICSP JP only have the 3D package. Okay, anyway, we can push. Slicing push to fusion. Okay, your Eagle board aspects actually push to PCB. Okay. Next, we need to open the Fusion 360. I'm afraid to my PC is going to crash or something. That's why the Fusion will be a turn on. And also for the custom shape, you can also you can also import custom shape as a DXF or bitmap. Okay. So you can, if you have any doubts, please post it here because I think our time is also limited. Fusion is turning on. Okay. Fusion is turning on. Starting up. Let's wait. I also use education license. Which software are you using commonly used to make custom PCB shapes or later files? For the 3D designing or something like that, I use two software. One is Autodesk 360, Autodesk Fusion 360, and another one is Rhinoceros. Rhinoceros is another software you can find here. This one, or we can use Autodesk Fusion 360. For the custom shape, I use Autodesk because it's very easy to push and pull the between the Fusion 360 and the Eagle software. Here we need to open our file Cisco. The file is here. You can see it's automatically uploaded to here. Make sure that you're using the same username and password. Nice. So actually, this is our PCB. You can see the module is this doesn't have any package. That's why it looks like this. Okay. This is our crystal. This actually doesn't have any 3D package. That's why it looks like this. Resistor have a good package. Okay. And for the custom shape, we need to go into the board and testing it first. And then disable all the layers. It's very slow. And I can sketch it right now. Some issues. Actually, the timelines. Anyway, I'll design a different kind of PCB right now. For that, we need to. We are going to make a PCB here. Create a 3D PCB. Actually, it's not existed anymore. It's very slow. So anyway, I think you got in the idea, right? Hello? And also in the Fusion 360 actually now capable of designing the PCB. You can see right now. So what you're seeing is actually the design actually you can create PCB using not only the Eagle, the Fusion 360 too. Yeah, create a PCB. So this is that. So this actually we are going to next we are if you want to do some kind of enclosure or something for that we are going to make first we are going to sketch it. Suppose we want to make an enclosure. Okay. This is so we just it's not actually the real one. I guess uh, the simplicity I just did that. So we just made a case. Okay. So it's actually not clear. You can see any problems here. So this is actually we do a product prototype. Okay, I think have any doubts or something? Hello, Agil.
Yeah, yes, Salman.
Uh, okay, so what are the advantages of and disadvantages of equal and fusion testing? So advantage and disadvantage score actually the PCB Eagle and Fusion 360 is owned by Autodesk. So currently uh, there is no limitation for the free edition we can use. There's no such thing as trial version or something like that we can use. So in future there might be changing to trial version something like that, as you go something like that. That's I only think that's the only problem. And also for the Fusion 360, it's only capable of designing small uh, 3D object since it works on a web, and also Fusion 360 need internet to work properly. Which is the best for using PCB design? Actually, it actually depends on the designer. So if you comfortable with the one software, and you can also jump to another software like uh, KeyCAD or OrCAD or something like that. Anyway, first try the Eagle. I think you mostly got the idea how to use how to make schematics and convert it into board layout, right? Next, we can next you can also try another software like ECAD or CAD or something like that. You get a student license for that. You just need to send a mail to them and try as much as can software, and you will at the end of the day you will like one software. There's no such a good software. While designing costs also important. Yeah, in designing cost is actually very important. In PCB designing, you can see uh, the design PCB cost is measured by this is size. So make sure that we are using small PCB. And also PCB, I'll show you PCB. Tab. So we can see some kind of the PCB cost when we are using 10 PCB number of pin and 10 how many layers we just need to layer. You can see the PCB cost in the right side. Actually, the PCB cost is $5, but the shipping charge is actually $18. Okay, please check. Select India. Select I use the FedEx. $19. The cost only for 10 PCB is $5, but the shipping charge is $19. It actually depends. If I use $14, the PCB cost is $700. If I use the size, if I increase the size, actually so I need a 10 centimeter PCB. Will again $100. It will be increased. So make sure that you better to use uh, less layer and less size always. And also don't use any unwanted components in your PCB, because you are not when we are designing PCB, we are not going to design one PCB. We are planning to make it 1,000 or 10,000 PCB. So it will actually make a huge change in cost. Okay. So you can contact me at the mail at semafars.co if you have any doubt, or you can also for example, I want to design oxiometry. What probability of getting defective PCB? Defective PCB getting is very less chance, because I just ordered 50 PCB, I think 50. I didn't get any fault in PCB, but also might be okay because it's a human process. So it will be with some errors. You can also, I said, I'm actually one of the member of Makergram community. So you can post, if you have any doubts, you can post here. So last week I already organized a PCB design workshop online for Rajagiri Engineering College students in Kochi. So this is a program. Have you already, and I just give some examples how we can use people and students can ask the question there. And also we for that we just designed a digital clock, and next day we designed the board layout for that, and also students also designed their own. So I hope you can also design your own PCB, and please submit if you have any work in online and everything. Yeah, this is actually a maker community. You can also join. It's free, and you can post your question and everything. Okay. I think we don't have any doubts on healthy. You can wait for 1 minute if you have any doubts. So, can we fabricate in India? Yeah, actually, in India there is one PCB power. These guys from India. I think Rajasthan something. These guys. PCB power. I don't exactly. I don't know this exact location. This guy is from India. And also Bangalore, there's some companies, and also in Coimbatore, there's actually many companies, and you can also use some kind of can use milling machines. You don't need to use the PCB manufacturing process. You can use the chemical etching. Yeah, the traditional way we do in college. You can use chemical etching or something like that. You can also use milling. You can use a CNC machine, and using the appropriate in our lab we are using modeler machine, and using that you can use, we are using 1/64 bit for the milling, 1/32 bit for cutting. So this is the FR1 grade PCB, and you can see the machine is milling. Here is our machine is milling. You can see this is the milling. Yeah, and we get the final PCB like this one, and we actually soldered. It's working. And see, I'll show you another some PCBs. Integration application. I did something. Yeah, this is actually we will be using PCB milling machine. This also work. Okay. So we have different kind of manufacturing method: chemical etching, PCB milling, and the final and good one is the PCB production. This one. So it can will help us to our key PCB last time. using the Silkscreen and everything. Okay, I think the doubt is clear. If you have any doubts in future, please log into makegram.com. You can post your doubt there.
Salman, one more thing, please note down your contact details as well. Maybe they can help them.
Yeah, my detail is I'll share. Better to
Yeah, either they contact on your Makergram team has.
yeah, I might not be available that time, but you can post here. The other people will help. I'll give you some example. You know the Kaushik, right? Kaushik is also from the your Amrita College. He's actually one of the member at Megagram. So he actually know how to design PCB. You can also contact him. And the best practice you can post it the Megagram. So every people can uh, uh, suggest the better answer because we don't know which is the best suitable answer for you. So this is a public platform. When we use a WhatsApp group or something, it's limited to only the 254 participants or something like that. But this one is public one, so everyone can get the answer and everyone can suggest some idea. So he's a design, he designed, and Kaushik did some uh, suggestions, some problem with the sales screen, and he suggested, and he just clarified the error like that. Okay. You can contact me. I'll be in active here and check this my profile. You can also send email message to yeah. No, I can message myself because I log in. So I'll check. I can send a message to Isha. Yeah, I can message to Isha. Okay. I think that's all.
Yes. So thank you so much for spending your valuable last 2 hours with us, and this is really awesome and really helpful for our students. So thank you once again.
Okay. And also one more thing to please this on- only attending the webinar you can design a PCB. Try it yourself. You will get some trouble and troubleshoot that. Then only you can be master of the PCB designing. Okay. Then only you can make PCB and master the tools. Okay.
Yeah, that's it. Okay. So thank you, Salman, and students. I hope you all of you are got a basic information about PCB designing. And in future, especially Amrita students, if you need any kind of webinar like this, you can contact the ThingQbator team. And especially during this lockdown period, we are ready to give free webinars. So if you need any kind of webinars, then you can contact us, either me or our ThingQbator team. And we have a student body in Amrita College. You can contact us. Okay. So thank you once again. Thank you so much. Bye all.